In this example, we have a single vector called a. We first have to find its magnitude, which means how long it is, or its size, and hence find a hat. This is a standard notation. That hat on top, little arrow, means it is a unit vector, but in the same direction as a. So first up, we can find the magnitude of a vector in either 2D or 3D using Pythagoras' theorem. So for this particular vector, the magnitude of 2 minus 1, 4, where we square each of the three components and add them together. It's Pythagoras in 3 dimensions, and then square root the whole thing. So the length of this vector is root 21. There's no point turning that into a rounded decimal unless the question tells you to. It's best to leave it as a surd. And do be careful when you're squaring minus 1 here. We must be squaring minus 1, so that's why I've put brackets around the minus 1. So hence find a hat, the unit vector, in the same direction as a. Well, any multiple of a will be in the same direction as a. Any multiple or any fraction of a will be in the same direction. And a unit vector, as the name tells you, have a length of 1. That's what a unit is telling us. They have a length of 1. So we need a vector in the same direction as a, but with a length of 1. So let's choose a fraction of the original vector. Let's divide it by its own length, and that will make it have a length of 1, which is therefore a unit vector. And the fact it is a fraction, or you could call it a multiple of a, means it's still in the same direction as a. Now, I've presented the answer 3 different ways here. There are even more ways you could give the answer. You could expand the brackets here if you want to. Any of these 3 versions would be correct for this particular question. So just keep an eye on the question, see what it wants, if there's any way it wants you to leave your final answer